Hi guys, here we are with your kind of full solutions to your gateway test if you're struggling with your trig topics, so that you have a chance to see how they're all worked with a little explanation if needed. So the first problem is that we're given the cosecant of an angle is 13/5 and it's in the second quadrant. So to work this type of a problem, I would draw the triangle in the second quadrant. So we would come over here. I would think about like SOHCAHTOA for the cosecant, which is the reciprocal of sine. So it's going to be hypotenuse over opposite, or r over y. So the radius is going to be 13 and the y is going to be 5, positive because you're in quadrant 2. And then what I would do is I would think about the fact that this is a 5, 12, 13. This would be negative because you are in quadrant 2 for your adjacent side. And then so our secant of theta is going to be your hypotenuse over your adjacent, or your r over your x. So from the triangle, I would pick the radius, which is 13, over the x, which is negative 12. So the final answer would be negative 13/12. All right, second problem, we want to find all the angles that between 0 and 2 pi that satisfy this equation. And taking a look at this has a 2 theta right there. So I need to use the technique of solving for all first and then find them in the interval. So I ignore that for the moment. I think about all the just angles that have a sine ratio of 0. Remember, sine is the y-coordinate. And sine, the y-coordinate, is only 0 on the x-axis. So for angles 0 and pi. So I know that initially 2 theta is going to equal 0 plus, and I'm going to use pi k. So that gives me all the angles going around half a circle that will have that 0 as a sine ratio. Then I simply divide everything by 2. 0 plus pi k over 2. Again, take a notice that what you have right here has to do with the period of the graph. And if I have a 2 theta, what you've done is you've done a horizontal shrink. So there are twice as many, or the period is half of what it used to be. So twice as many periods between 0 and 2 pi, or half the period that it used to be in between those. So once I have that, I basically let k be 0, 1, 2, 3, and so on. So our actual answer to the problem is going to be, if k is 0, it would be 0. And we're brackets, so I'll include it. If k is 1, I would be pi over 2. 2 would be pi. 3 pi over 2. And then 4 would be 2 pi, but it's in parentheses, which means do not include it. So that gives us our answer for that. And I like to highlight my answers. So there, and that's my answer for number 2. Okay, for number 3, it's just a substitution. If x is this, plug it in and simplify. That's where the key to this is. So the square root of x squared plus 4 is going to become the square root of 2 tangent theta squared plus 4, which is going to be the square root of 4 tangent squared theta plus 4, which is going to, let me give myself a little bit more room here. I'm going to factor a 4 out. This is just some algebra simplification at this point. 1 plus tangent squared theta, because what I'm doing is I'm revealing that this is a Pythagorean identity. So our 1 plus tangent squared theta is actually secant squared theta. And now I have 2 perfect squares. And so the square root of 4 is 2, and then the square root of secant squared theta is absolute value of secant of theta, because remember, principal values, the square root is always positive. And so this simplifies to 2 absolute value of secant of theta. All right, so we'll highlight that as our answer. Now, going on to the next problem, we have our cotangent over cosecant. Again, we're just playing around with simplifying using identities. Cotangent is cosine theta over sine theta. Our cosecant is 1 over sine theta. And if you basically flip and multiply, it will cancel and simplify to cosine theta, and we're done with that problem. Pretty easy. All right, over here, we're utilizing our double angle identity here in number 5. Find the sine of 2a, given that sine of a is 1/4 and a is between 0 and pi over 2. I'm going to essentially come over here and do the triangle. You'll notice that a lot of these problems we're practicing those reference triangles. Sine is opposite over hypotenuse. The third side would be square root of your hypotenuse squared, 16 minus 1. Your leg squared, which is square root of 15. So find that third side. I think about identities. The sine of 2a is 2 sine a cosine A, and I just basically have to then get those values, trig ratios, from my triangle. So I would have my 2 times my sine of A, which was 1/4, times the cosine of A, which is adjacent over hypotenuse, so square root of 15 over 4. And then my final answer, I'm going to come over here, is going to be the 2 and the 4, 1/2 square root of 15 over 8. So that's how we get the answer for that problem. All right, taking a look at the solving, factoring problem. Notice you have a GCF of tangent of theta here, so I would factor out tangent of theta. 2 cosine theta plus 1 equals 0. So we have two equations because we have two factors, either tangent of theta equals 0 or 2 cosine theta plus 1 equals 0, cosine theta equals negative 1/2. Now in unit circle, tangent is 0 at 0, and it has a period of every pi, so 0 and pi and so on. So this would be theta equals 0 plus 2 pi k, or between 0 and 2 pi, 0 and pi. I'll leave that open because I'll come over here. Cosine is negative in quadrants 2 and 3 because of the negative x. We are in the pi over 3 family. It's unit circle. I know that the coordinates of the pi over 3 family are the 1/2 square root of 3 over 2. Cosine is the x coordinate, so I need that. And I need the members in quadrant 2 and quadrant 3. So I'm doing my pi minus the reference angle and pi plus the reference angle. So pi minus would be 2 pi over 3, and pi plus would be 4 pi over 3. And then those are the answers because they wanted between 0 and 2 pi. All right, number 7 is very similar to number 5, using the double angle formula for cosine. Remember there were 3 versions of that, and since I know the cosine of 2 theta equals 1/3, I would probably go ahead and switch that to the one that only has the cosine. So I would do an identity substitution and make this 2 cosine squared theta plus 1 equals 1/3. And then I would go ahead and solve that. So I would subtract 1, which is going to give me negative 2/3, and then divide by 2, which is going to give me cosine squared theta is equal to subtract 1, negative 2/3, divide by 2 would be negative 1/3. And then take the square root of both sides, and we get cosine of theta equals, hold that thought, I have a mistake. See, everybody makes mistakes. It should be 2 cosine squared theta minus 1 here. I was like, all of a sudden, I was like, wait, just a second, something's not right. Why? Because you can't take the square root of a negative. See, there you go. Figuring out when you make a mistake. So over here, this would be 4/3, add 1 to both sides, then take the square root. Now, technically right now we're at plus or minus the square root of 4/3. Now what we need to do there is figure out whether I'm plus or minus. You need to come over here and look at the 0 to pi. And if 2 theta is in between 0 and pi, theta is in between 0 and pi over 2, which is quadrant 1, which is the positive square root of 4/3, or 2 over square root of 3, or 2 square root of 3 over 3, different versions of that. And I made another mistake on this. I forgot, I'm just going to come back and just erase this part of it and go, I had 2 cosine theta equals 4/3. 2 cosine squared theta equals 4/3. I forgot my 2 when I had over here. And then I divide by 2, which is cosine squared theta equals 2/3. So cosine theta equals plus or minus the square root of 2/3. And then because of the same reasoning that I just said over here, we know that cosine of theta is the square root of 2/3. All right, so our final correct answer, square root of 2/3. All right, so now taking a look at this next one. Again, this is the one where we're trying to write it in algebraic form to eliminate the trig function. So I showed you the example in the review. So this wants to find the tangent of the angle whose cosine is x/3. So I'll come over here, and the cosine is a principal value range of 0 to pi. So we're talking quadrant 1 or quadrant 2. Cosine is the adjacent over hypotenuse, or the quote-unquote x-coordinate over the hypotenuse. So that's x/3. And you'll notice that kind of in this problem, regardless of where you are, if x is positive, you would be in quadrant 1. If x is negative, you would be in quadrant 2. So it sort of matches your principal values. Your y-coordinate is always going to be positive. Again, we just simply use Pythagorean identity, hypotenuse squared minus leg squared. And then we're looking for the tangent, which is opposite over adjacent. So our final answer, square root of 9 minus x squared over x. And it would be the same thing over here. Because you're in quadrants 1 or 2, the y is always positive. So in both situations, it would be the same answer. And then our final problem in our trig review packet is find the angle whose sine is -1/2. This is where you do need to pay attention to the principal value range. And you do need to know them for each of the trig functions. The sine principal value range, you're always returning answers from -pi/2 to pi/2. And so I'm looking for where sine is negative, and sine is the y-coordinate, so I must be down here in quadrant 4. But be careful, don't pick, I mean, you have to know what family you're in, which is the pi/6 family. And so we know we're in the pi/6 family, but do not pick 11 pi/6. That would not be correct because that is not in between -pi/2 to pi/2. You have to think of it as a number line. So the coterminal angle to 11 pi/6 that is in the right window would be -pi/6. So this answer is -pi/6. And those are all of your trig review from your gateway tests.